So this is x squared minus 6x and plus 8. So the shape is given by the leading coefficient. The leading coefficient is 1, the middle coefficient is negative 6, and the free term is 8. Since the leading coefficient is a positive number, we know from transformations that the quadratic function has a minimum. In step number 2, I will have to determine the vertex. Oh, I know how now. This is negative b over 2a. Copy the negative. Copy b, which is negative 6. Copy a, which is 1, times 2, which is 2. This is negative 3, but with minus in front, this will be 3. Now I have to determine the y-coordinate of the vertex. All I have to do is plug in 3. F of 3. So 3 squared is 9, minus 3 times 6 is negative 18. I mean negative 6 times 3, I meant to say, plus 8. So this is 17 minus 18, which is negative 1. Good. In step 3, X-intercepts, comma, if they exist. What does that mean if they exist? Yes, they don't have to exist. Two distinct real solutions, one real solution, no real solutions. They don't have to exist. However, I know that the vertex, that's another very important point, is at 3 comma negative 1. So where is 3 comma negative 1? 1, 2, 3 comma negative 1. So it's somewhere here. Well, the parabola has to cross the x-axis. If the vertex, the y-coordinate of the vertex is 0, then I know the x-intercept and the vertex are the same. If the y-coordinate of the vertex is positive, then I know there are no x-intercepts. But in our situation, the vertex has a y-coordinate of negative 1. I can already picture the range. If it goes to negative 1, the range is negative 1 to infinity. So they exist. I'm not going to waste my time. They do exist. Good. How do I determine the x-intercepts for any function? What do I have to write? What do I have to write in order to find the x-intercepts for any function?
When y is equal to 0.
Perfect. Indeed, when y equals 0, but what is y? X squared minus 6x plus 8 equals 0. I have 4 methods, but I'm going to use this because it's the easiest. It doesn't take a long time. So then I have 2 ordered pairs that represent the x-intercepts. Can anyone give us the ordered pairs that represent the x-intercepts? And then we move on to step 4. So 2 for x, 0 for y. 4 for x, 0 for y. Now the y-intercept, which will always exist. How do we get the y-intercept? What do I have to determine? When x is 0 this time, f of 0 is easy, 0, 0, 8. So we have 0, comma 8 as the y-intercept. Step number 5. Range. You can say, how can you find the range without graphing the function? I already know. It must be negative 1 to infinity. It has a minimum, and the minimum value is given by the y-intercept, by the y-coordinate of the vertex. Number 6 and number 7. So we know that the parabola will look like this We know that this will be its vertex, which is 3 comma negative 1. There is what it's called, we're not talking about odd or even functions. We know that there is what it's called a vertical line, not part of the graph, but this is the axis of symmetry. It's the vertical line through the vertex. It must be x equals 3. So when we are, in a minute when we get the chance to graph the function, it will be symmetric. It will be symmetric with respect to this line. Anywhere we graph it. I'm not saying the function is odd or even. I'm saying its graph could be anywhere. It will be symmetric with respect to this axis. And number 7 is the minimum in this case. Min value is negative 1. It's the y-coordinate of the vertex. So the last two really are readings from the vertex. The axis of symmetry, x equals 3. The minimum value, or the maximum, if it's a maximum, is negative 1. Now we are ready to graph this function. We will always start with the vertex. So here's the vertex at 3 comma negative 1. We will always continue step 2 with the axis of symmetry, not part of the graph. X equals 3. Then we will plot the x and y intercepts. I go back. The x-intercepts are 2 and 4. They have to be symmetric with respect to x equals 3, 4, and 2. And also we have 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. I will try to make this graph as symmetric as possible. Not too acute at the vertex. So this is the graph of f of x equals x squared minus 6x plus 8. And as you see, of course, the range is negative 1 to infinity. Any questions? Okay, I would like to look at a word problem. I know I did not forget to go back to this. We only analyzed the function that is quadratic given to us like this, not with the perfect square in it. Okay, I would like to look at a word problem, and if we have time today, we'll go back to the other one. But a word problem is more important at this point. So on page 361, I would like to look at 58. And here is the problem. I'm trying to magnify it a little bit on my computer. Oh, perfect. Okay, it says, when the shot whose path is shown by the red is a graph, we don't need to look at that, on the previous page is released at an angle such and such. We are given a function. G of x equals negative 0.04 x squared plus 2.1x plus 6.1. X is the shot's distance. I'm going to graph for you this function. When x is 0, 6.1, 1, 2, 3, 4, 5, 6, somewhere here. Obviously it has a maximum. How do I know? Because the leading coefficient is a number less than 0. So we throw it up in the air, it reaches a maximum and then it comes down and hits the ground. So this is function g of x. Where x is the horizontal distance. Horizontal distance. And y, or g of x, is the height. So height of the shot anywhere. At when x is this, when x is this, when x is this. So all this function gives us the height at any point, from the moment we throw it up in the air till the moment it hits the ground. Okay, let's see what they want. First question, what is the maximum height to the nearest tenth of a foot of the shot, and how far from its point of release does this occur? So what are we really asked to determine? Can anyone tell us the word? There is one word that I would like you to say. We're asked to find the maximum. So when we're asked to find the maximum of a quadratic function, what are we really asked to determine? We're asked to determine this point, which is called, only for quadratic functions, how is it called? The vertex. Only for quadratic functions. So it's the maximum. So we know it's a maximum. And how do I find the coordinates of the vertex? And this will tell us where, right here. And this will tell us how much. So how do I find the x-coordinate of the vertex in this situation?
Negative.
Brilliant. Very brilliant. Thank you very much. Negative b over 2a, of course. Make sure that the function is presented in descending order. They may try to confuse you, but it is in descending order, so I can correctly identify a, b, and c. Negative b, negative is outside, b is 2.1. 2 times a is negative 0.08. So, 2.1 divided by 0.08 is 26.25, and we want to make sure everything is given in feet. Perfect. So this is 26.25, which means this is 26.25 feet. Good. How do I find the maximum height?
The function of x?
Yes. So I have g of 26.25. So let's see what we get. Negative 0.04 times 26.25 squared plus 2.1 times 26.25 and plus 6.1. Let's see. Negative 0.04 multiplied by 26.25 squared, and then plus 2 multiply, no, 2.1 multiplied by 26.25, and then plus 6.1. 33.6625. Also feet. Good. Next question. What is the shot's maximum horizontal distance when it hits the ground, basically? So this is the maximum horizontal distance. Max horizontal distance. How do I find that? And what does this represent? What does that point represent for our function? What does this point represent for this graph? It's the x-intercept. So we have to make y equals 0. So negative 0.04 x squared plus 2.1 x plus 6.1 equals 0. You know me. I refuse to solve a quadratic equation with a negative leading coefficient, but that's me. 0.04 x squared minus 2.1x minus 6.1 equals 0. And now we can, I would have normally multiplied by 100 to eliminate decimal numbers, but that's okay. Negative b plus or minus b squared minus 4 times a, but since this is negative, I'm changing this into positive. So I don't have to use nested parentheses. Over 2 times a. Be very careful how you put this in the graphing calculator, because obviously we need parentheses around the top and we need parentheses inside depending on your calculator. So left parenthesis 2.1 plus the square root. I normally put parentheses inside. 2.1 squared plus 4 multiplied by 0.04 multiply by 6.1, close the parenthesis, go outside, close the parenthesis, and divide by 0.08. I got 55.2697. 55.2597 feet. And you can say, but what a minute, you haven't determined the one with negative. Here's how I do it. And copy the whole thing and overwrite. Of course it's going to be a negative number. How do I know? Because the other intercept will be a negative number. It has to be a negative number. So I press enter and I got negative 2.7597. Who cares? Final question is asking us from what height was the shot released. From what height was the shot released? Of course, I'm asked to find the y-intercept. So, final. When x is 0, f of 0 is 6.1. So 0, 6.1 feet. Any questions? Any questions? Okay, finally I'd like to finish up with one example of the other kind. Let's say negative x plus 2 squared plus 4. Same steps. Step number 1 is the shape, which I know the leading coefficient is -1, so it has to have a maximum. In number 2, the vertex is the easiest thing now. I don't have to do anything, I just have to read it. Because the coordinates of the vertex, remember we know how to graph this in a blink. So we had x squared, right? Then x plus 2 will shift the graph to the left, 2. Then we have to reflect. And then we have to go up 4. So I know the vertex, -2, 4. And these are those coordinates that I mentioned a few minutes ago. The vertex has coordinates h, k. So no calculations are required if the function is given to us in this format. We have everything squared. The perfect square is there, which means -2 because of the negative. -2 is the x coordinate of the vertex, and 4 is the y coordinate of the vertex. The rest is the same. The x-intercepts, do they exist? Yes. I already graphed it. Of course they do. I have to make y equals 0. So I get this. I multiply both sides by -1. And I take the square root. And now I have to have plus or minus. And then x equals -2 plus or minus 2. And I have two options as -4 and 0. or negative 4 comma 0 and 0 comma 0. Everything is the same. Of course, now I know the range. I know the y-intercept is already determined. I don't have to write it again, but I will write it again. Y-intercept, f of 0 is 0. 5, 6, and 7. So 5 is the range. I know the range. Negative infinity to 4. The axis of symmetry is because the vertex is negative 2 comma 4 right here, x equals negative 2, and because the vertex is negative 2 comma 4 and the function has a maximum is 4 from the range also. So I can graph now. I always graph the vertex first. I have to continue with the axis of symmetry in order to keep the graph in shape. The x-intercepts are 0, 0, and negative 4, 0. They have to be symmetric. If you get an x-intercept at 0 and the other one at negative 10, you know something is terribly wrong. And the y is 0, 0 as well. So this is the graph, which you already know. We knew everything because we graphed it using transformations, which I couldn't do with the previous one. But this one, perfect. That's why we studied transformations. And this is the function f of x, negative x plus 2 squared plus 4.